Okay, page 8, number 16. Okay, so on this example, it was hard to isolate something. Okay, can you see that I can't really isolate a radical? So what I'm going to do is I'm going to square both sides. Okay, so on the left-hand side, it's pretty easy. It just becomes 3x plus 2, right? Squaring a square root, just gone. On the right-hand side, because it's squaring a binomial, you cannot shortcut anything. What should I do? I'm going to write it twice. I'm going to write it twice. Okay, squaring a binomial creates a FOIL. We don't square things individually. We square it as a group, a unit, right? Remember that? I've said it 20 times because it's important. Okay, so we're going to go slow and steady on the FOIL. Here we go. First times first. What's the whole number part of it? 9. What's the radical? What happens when you do a root x, root x? It becomes just a whole x, right? Because the roots disappear. Outsides. Okay, I got my fingers on the outside items. What's the whole number piece? What's in the front? -3. Radical, what's all with the radicals? 2x. Bless you. Insides. What do you have? Would we agree it's the same thing? A -3 root 2x. Do you see it? -3 root 2x. Last times last. Well, first of all, minus minus makes a plus. What happens when there's a root 2, root 2? Okay, so here would be my algebraic strategy now. Anything radical will get grouped together on one side. Everything not radical will be grouped together on the other side. Does that make sense with algebra? So let's put these together. So if you have, how many root 2x's do you have? You have -6 of them now. I'm going to be moving this over, so I'm going to have to minus a 9x, and I'm going to have to minus a 2. Let's see. So then this is -6x. That's a 0. Now what? Go with your algebra instincts. What are you thinking? Divide. Now I'm going to square to get rid of the radical. Okay, so all that, and now we're at old past algebra. What do you do when you see x squareds and x's? What's always the rule? If you see x squareds in there and x's in there, 0, right? 0 it. Okay, as soon as you ever see x squareds and x's, you 0 it. And then you go into your strategy bank. Can you factor this? Yes, and I heard it. Somebody yelled GCF. X out. Okay, so now what I should do is check my answers. So I'm gonna plug in a 0 here. Okay, so if I was to plug in a 0, I'm just gonna cover that, and this side would be root 2. If I was to plug a 0 in, this would be gone, but then it would say negative root 2. What do you think about that solution? That doesn't look good. That's not equaling each other, right? So now let's try plugging in the 2 to see if we did that right. So 3 times 2 is 6. 6 plus 2 is 8. So root 8, 3 root 2 minus a root 2. If I plug that in. So 3 root 2 minus 1 root 2 makes 2 root 2. And I need you to break this down. It's one of those that breaks down. How do you break something down? What kind of perfect square is 8 divisible by? Root 4 times a root 2. And what is the square root of 4? 2. Root 2. Look at that. That worked. Okay, some of you might have just typed that all into your calculator, and that would have been fine. But this kind of work is gearing you up for grade 12 on a provincial when you can't use your calculator. Okay, number 17, we're going to do a very similar thing. So I don't want to square this side with it having 2, so I'm going to just move this over. Okay, so now I'm going to square both sides. Square both sides. So square this side, square this side. It helped us in making the one side simplified, right? 2x plus 3, nice and simplified. But here, guess what happens? I have to square a binomial. Squaring binomials, right? Okay, so give me the FOIL breakdown. Go slow and steady on these. First times first, 1 times 1. Outsides one of those roots. Insides one of those roots. What happens to the last times the last when you do a same root times the same root? It drops the root, right? A same root times the same root drops the root. Okay, so now, what do you think my strategy is? Radical stuff will be on one side. Not radical stuff will go to the other side. So this means I have 2 of those. I'm going to have to take away an x. Are you okay if I go minus 2 to get rid of that and that? Does that make sense? This is 1 plus 1, so there'd be a 2. So I'm going to minus 2. You see that? If I shortcut. Okay, so we get x plus 1 equals that. Okay, now I still have a radical. So what am I going to do? Square both sides. Okay, so square, square. Oh, this is a binomial getting squared. So I'm going to have to FOIL again. Okay, now this, you're squaring it, so you're repeating it twice. You don't have to write this, but what am I doing? I'm repeating it twice. So what happens to the front number if you repeat it twice? 4. What happens to the radical? Radical times the same radical drops the radical. Okay, I just did some collections, some distributions. Now what? What would be a good idea at this point with your algebra stuff? You know all these tools from somewhere. X squareds, x's, so we should do what? Give me a 0. I need to have a 0. So x squared minus 2x minus 3. Does it factor? 3 times 1. Okay, now you're going to have to check your answer. So let's talk about if we were to plug a 3 in. So 2 times 3 is 6 plus 3, so it'd be the square root of 9 minus, if I put a 3 into this, 3 plus 1 is 4. 3 minus 2 equals 1. Yeah, that ended up working out, right? Okay, what about -1? So here I go. 2 times -1, that's a -2 plus 3 gives me a square root of 1. -1 plus 1 is a 0. Actually, that works out too, right? Because this is 1 minus 0. So on that one, they both worked out. Okay, so it's important to just make sure you're plugging in your answers as well.